Let's work on this one. All right, so we've been talking about how graphs can be translated into these equations and how these equations can be easily solved using these graphs. Now, for the most part, all I've been doing is I've been setting y equal to 0. And when I say solve something, I've been asking you, where does this thing equal 0? Where does it cross the 0 axis? For example, if we were to solve this problem right here, y equals x squared minus 1. That's my general equation. It would be that. And then if I say, well, where does y equal to 0? I would kind of think, okay, well, where does it cross this line right here? That would be at positive and negative 1. Positive 1, negative 1. So this answer right here for part B, plus or minus 1. We cool? Now, you don't need to always have it equal to 0. You can say, okay, well, where does this, this question over here for part A is saying, what are the x values such that it gives you a y value of 3? So I say, well, okay, well, what x values make it the graph cross this imaginary dotted line that I'm putting in my head at 3? And you can read that off the graph. Let's see, at y equals 3, I'm looking at negative 2 and positive 2. So I've got positive 2, negative 2. So I can just put in plus minus 2. And y equals negative 1, so then it says, where does the graph cross this imaginary line? There's an interesting thing about this point is, at this point, it only crosses one time. Whereas on all the other points of the problem, it crosses twice. So you simply say, well, the x value at where y equals negative 1 is actually 0. It's right dead in the center. We cool with solving those kinds of problems? Awesome.